The Moon, with its lack of air, water, and temperature extreme fluctuations, poses numerous challenges for space agencies planning lunar missions. One of the most persistent challenges is lunar dust, which can erode spacesuits, clog machinery, interfere with scientific instruments, and hinder movement on the lunar surface. Addressing this issue has become a priority for space agencies like NASA as they aim to establish a permanent lunar presence. Proposed a unique solution to tackle the lunar dust problem, using a giant lens to melt lunar dust and create solid roads and landing areas on the Moon's surface. This unconventional approach could help space agencies avoid the costly transportation of building materials from Earth to the Moon. The dust problem. Lunar dust has been a persistent issue during previous lunar missions. For example, the Surveyor 3 spacecraft was damaged by dust kicked up during the Apollo 12 landing. Lunar dust is not only a nuisance but also a potential contaminant, as it can affect equipment from different missions and nations. Experimental process. Scientists, including Professor Jens Gunster from the Federal Institute of Materials Research and Testing in Berlin, conducted experiments using a fine-grained material called EAC-1A, developed by the European Space Agency as a substitute for lunar soil. They used a 50mm laser beam to heat the dust to approximately 1,600 degrees Celsius, causing it to melt. The researchers traced out bendy triangle shapes, each around 25 centimeters across, which could be interlocked to create solid surfaces on lunar soil. These surfaces could serve as future roads and landing pads. Challenges and future prospects. While the concept shows promise, the process is not rapid. Each small geometric unit took about an hour to produce, suggesting that creating a 10 by 10 meters landing spot would take around 100 days. To implement this approach on the Moon, researchers estimate that a lens of approximately 2.37 square meters would need to be transported from Earth. This lens could be constructed from a polymer